Hello. Ooh, nice. I like how these microphones improve my voice. All right, so let's get started. Is this thing working? Yeah, sure. All right, so Zuul and Kubernetes. I'm going to give a bunch of disclaimers in a bit, but what I'm going to be talking about is how to run Zuul as a CI platform on Kubernetes, and not so much about how to use Kubernetes as a compute workers for Zuul CI jobs. Although I do have like a single slide somewhere in there because we are doing that. Well, actually, before I go into my slides, who's we? I currently actually work at Elastic. If you know anything about me, you know that I used to work at Red Hat, and I did that for long enough time. Since this year, I moved to Elastic, which we do nothing with OpenStack. And the reason I'm here is because we're starting to look into Zuul for our CI solution, and I promise I had everything to do with that. And again, I'm going to give a couple of disclaimers in a bit. That is my Twitter handler. If you have any feedback or want to follow me or anything, do it. Someone has to feed my ego, and that's you. All right, disclaimers. I think the first and most important disclaimer is that while we're trading, or at least, and when I say we, I mean the infrastructure team at Elastic, which I'm part of, and what we do is we do engineering operations for the company. So we provide services to the rest of the engineering team, and not so much to the client, although we do have some services that are customer-facing. The reason I'm saying this is because this is important to the topic of CI within Elastic, because we are the ones that run that, we are the ones that manage CI, and that's the reason why we're also looking into improving our CI story. So while we treat our current, let's call it POC deployment of Zuul as a production environment, we are still not fully functional on Zuul, so Zuul has not been picked as the official CI solution yet for Elastic. Hopefully, we'll make up our minds very soon, but it's a very good contendant against any other tool that we're also evaluating. We're still learning many things. Although I was part of the I still feel like I am actually part of the OpenStack community for a very long time. I was a very, very happy Zuul consumer and not a Zuul administrator or operator or developer for that matter. So there are many things I'm learning about Zuul, about its architecture, about the way it works, about all the configurations it has, and about all the capabilities it has. And especially about how you can define things and explain and describe things in Zuul lingo. And whatever I say today, it may not be true tomorrow as far as our deployment goes. We might change the way we run things. We might decide that this is not the tool that works well for the team. Although if that is the result, I will definitely not have anything to do with that because I do like Zuul and I want to use it. So getting into the content, why on Kubernetes? And again, the battle between metal and virtualized environments keeps going on. Right now, just to give you some context, Elastic uses Jenkins as the CI solution, and there's a mix of things in our current deployment. There's Jenkins, which is the thing that actually runs and schedules the jobs, but these jobs are scheduled using a different tool. So Jenkins runs on VMs. For each of the teams. So each of the team within Elastic has its own Jenkins deployment, so its own Jenkins cluster or set of masters, if you will. And then these Jenkins masters, they talk to another centralized tool that is called GoBuild. And for those, so GoBuild is the thing that creates VMs in the different clouds that we run load on. So GoBuild is basically node pool, if you're anything familiar with Zuul itself or its architecture. Now, the reason I'm describing this architecture is because GoBuild runs inside Kubernetes. So we have a mixed deployment between things running in Kubernetes and things running on VMs and other things running on bare metal nodes. which is a freaking mess, honestly. So one of the ideas is to consolidate all these things and have everything running in a platform that the rest of the team is familiar with, and that it's just going to make easier to debug things, which I'm not saying that Kubernetes makes things easier to debug. I'm just saying that having the same platform for everything is probably going to make it easier for people to familiarize themselves with the deployment. So one of the reasons to run things on Kubernetes is because we don't really know how to run Zuul, and we don't know how much capacity we need for it. And since capacity planning is not easy at all, and no one has ever said that it is easy, and if someone said that, they're lying, and they don't know shit about, capacity planning. But the clicker went nuts. All right. But the real reason is because we're heavy users of Kubernetes within the infrastructure team. So we have a bunch of things running on Kubernetes, and we have multiple Kubernetes clusters. So we said, like, if we want to run this thing, we probably want to keep running it inside Kubernetes as well. So Kubernetes is not this really, I'm not going to come here to kind of like pitch Kubernetes to you. The reason we're using it is because we already had it installed, and again, we are familiar with it. But there are two things that definitely make running Zuul inside Kubernetes easier, at least for us, specifically in this phase here, where we're learning many things and constantly changing configurations in our deployment. So one of them, and which is also one of the reasons why we decided to try Zuul and install it within the company, is that Zuul is fairly simple to scale. It's really simple to just add more services of it right next to the others, right? And the Zuul architecture is very, very microservice oriented. So if you want to scale it, you pick the service that you need to scale, whether it's a web server or the executor, or you can scale the scaler, I'm going to get to that, or node pool launcher, whatever you want to scale, you just add more of those to your cluster, and then you're going to be able to manage more things. I'm done with this. Okay. Actually, I'm just going to unplug it too. So upgrade with one PR and one command. Everything that we, and you're probably familiar with this, is if you're familiar with the OpenStack community, everything we do goes into the source control management system, which is Git and GitHub, and everything is done through that. If you want to upgrade Zuul, we just basically submit a patch to our repo, merge it, and it's gonna take whatever we have and upgrade our Zuul deployment. And the same thing for all the configurations that we have. And again, I'm gonna get a little bit more into that in a bit. So what are we running from Zuul? This is our little Zuul deployment, actually. And you might say, like, well, this is definitely a POC, but I can tell you that this little deployment here can actually run a great amount of jobs. And one of the fantastic things about Zuul is that with very little, you can support big enough use case or big enough load. So everything we run is basically deployments on Kubernetes, except for two services, which are the executor and Zookeeper, which run on using stateful sets. And I'm going to get on why we're running the executor as a stateful set and not a deployment. So we only have one webhead, we only have one scheduler, we only have one node pool launcher, and right now we have two executors. And for a while, we only had one executor because as we were rolling out the deployment, having one thing of everything made it super simple for us to test and debug our configurations. If you have multiple executor nodes running and you run your job, then eventually you don't know what executor is actually going to be running the load for you, and then you just have to go and chase the job across the entire set of executors. So we did that for a while. Now we have two executors. I don't have the exact numbers, again, of how many jobs we're running per hour and how many patches we're testing. Definitely far from whatever OpenStack is doing these days. But it's a good deployment to start playing and testing this thing. So we don't run Zuul merger. One of the reasons is actually, the main reason, the only reason, is because we have everything on GitHub, and GitHub does the merges for us. So we don't really need to be We don't really need the Zuul merger server to be merging code for us and pushing it to the repo. And as far as I understood, like the executor is the one that triggers the merge action on GitHub for us, and then GitHub is the one actually doing the merge. So we don't need neither the executor to do the merge for us, nor the Zuul merger server to do it, which actually simplifies even the deployment even a little bit more, because we don't need also the merge check to verify whether there are conflicts within patches or not. We're not running the Zuul finger gateway yet. Again, Zuul uses the finger protocol to to send text basically from the console and the executor into whomever connects to the finger protocol, which is the same one that Zuul Web uses to stream the logs from the executor into the browser whenever you want the live stream. So if you're running a Zuul job and you go to the live stream, that is a WebSocket connection to Zuul Web, and Zuul Web uses the finger protocol to get all the text from finger and from the executor and pushing it out to the browser. So that's pretty much it about what we're running from Zuul. So how are we running it? How do we run it? We run it slim and tight for now, again, because our use case and our needs are very small for now. Although I can tell you, like, Elastic's load for CI is pretty high. If I look at the numbers of patches merged in within a month and per hour, so the monthly number is quite close to what OpenStack does every month. The hourly number is not that close. I'm avoiding saying all the numbers out loud for now, but we can talk about it later. But it's a very specific use case, and the needs are very similar to the ones of OpenStack. And I think one of the things that differ between the Elastic needs and the OpenStack ones is that Elastic has the requirement of testing every software in multiple operating systems, which we don't do in OpenStack. So we do have the requirement of testing every part of the stack in multiple Windows versions and multiple OS X versions, as well as multiple different Linux distributions and different architectures, from 32 bits to 64 bits in some cases. So the test matrix, let's say, is pretty wide. But for now, given that we don't have the entire company running their load on this, like we're able to run it like very slim and tight for now. So everything is managed by Helm and Terraform. And again, everything goes into the source control management. I wrote, and I haven't published it in any public repo yet because I've been too lazy and just having fun playing with this thing. But I wrote a Helm chart for Zuul, and I believe Mohammed also from Exos, he also has one. And I realized I should have probably talked to him before writing mine. Eventually, we're going to be, hopefully, I'm going to be converging them. And I'm happy to trash mine and just take his, because he's way smarter than I am. But for now, I do have a Helm chart that I'm using to deploy Zuul. And the Helm chart, so the second reason why it is not in a public repo right now is because, again, we do everything through source control. And it was fairly simple for me to just like push the Helm chart inside our repo and have our Terraform configurations taking the Helm chart, building it, and then just updating my Zuul deployment. And again, like everything we do, as far as deployment goes, uses Terraform. So even the Helm chart deployment is done through Terraform, and all the states are kept there. So all is Helm and Terraform. The Zuul executor. The Zuul executor is probably the part of Zuul that requires more tricks within Kubernetes. Now, one of the things about Zuul is that it reads its configurations from a single file. There's no way to tell Zuul, hey, pick every .conf file from this directory and build a configuration file for me and read all the configs from there. So since that's the case, and a few other things happen within Elastic, which I'm going to explain right now. So we use Vault internally to store all of our secrets. Vault, when I say Vault, I mean the HashiCorp product Vault. So we have it, and that's a source of truth for us when it comes to storing secrets within engineering. So whenever someone needs to store credentials for a Google Cloud, or credentials for a Docker registry, or credentials for databases, it all goes into Vault. Then that combined, all right, so we have all our credentials in Vault. Now we need to make these credentials available within Kubernetes somehow. We don't want to duplicate these credentials. We don't want any engineer like pulling down the credentials from Vault manually and creating secrets on Kubernetes. Now, I did mention that everything that we do goes through source control. Now, we also don't want anyone downloading the credentials from Vault, putting them in the source code, and like the Helm chart in this case, and pushing it into our repo, because in that case, well, the secret is not secret anymore. So we have that combined with the fact that we're doing everything on source control, and the fact that we don't want anyone creating secrets manually on Kubernetes made this, an issue for us, because we need to make the secret available in Kubernetes and have it, magically appear in Zuul's config file. So I can't create a config file that has only, a portion of the Zuul configurations, because again, Zuul is not capable of reading multiple config files. So what we did is we created a Zuul template, a config file template that we render in a init container. So if you're not familiar with init containers are containers within the pod that run before the actual container runs. So there's a trick here, which is that I'm mounting a volume in the init container where I render the file and I write the file to that volume, and then that volume gets mounted in the actual container that runs that Zuul executor. Now, this is how we generate the config file. This is how we render the config file. Now, how does the secret go from Vault into the secret? We use something called Kube Vault Controller. It's a project that was created initially by someone from Datadog, and now we are also maintainers of the project. And so what this project does is you can create a secret claim. Is a CRD within Kubernetes. You can create a secret claim. When you create a secret claim, this controller goes into Vault, reads the data, the secret, and just creates a secret for you inside Kubernetes and makes it available within the cluster in the namespace. So that way we can make the secrets available within the namespace and also be able to render the file eventually. It's a bit tricky to just like say it out loud without an actual diagram or picture that makes it better, but bear with me. So talking to the executor pod is another challenge, air quote. Remember the finger protocol and Zuul web connecting to using the finger protocol to the Zuul executor. Now within the Kubernetes namespace, there's no way from one pod to connect and talk to the other pod unless you create a service and they're like within the same network context and all that. Since the Zuul executor is the one, streaming and pushing all the logs into the protocol, and Zuul web needs to connect to it, the way to make this work, and like if you're running these in VMs, it's fine. Like you can just like listen to localhost or point Zuul web to the actual executor IP address, and it's all going to work. If you do this within Kubernetes, then you have the problem that they're not seeing each other, and there's no way to actually route the request to the Zuul executor. So a way around this is using stateful sets. So this is the only reason why we're using stateful sets for the executor. So by using stateful set, you can leverage something called a headless service in Kubernetes, which basically creates a service, in Kubernetes lingo, it creates a service that is not totally exposed to the external network, so to speak, but is available within the cluster. So by creating this headless service, and this is created automatically for every stateful set if you have the right configs there. So one of the right configs that you have to have is the service name. If you don't set the service name, the headless service is not going to be created. So what we basically do is we added the service name to our stateful set, so that for every pod we can reach the pod using the pod name plus the service name. And that is how the Zuul executor, sorry, the Zuul web can actually reach the Zuul executor and stream all the logs to the web browser, which is a very useful feature. And like most of the developers ask for it, like, we want to see what's going on. And I was like, well, if only it was happy and easier to do. Leverage. All right. So another issue about Zuul executor is that it requires privileged permissions to run within Kubernetes. So for a while, I thought it needed also admin access, and I had like admin set it to true, or by admin I mean run as user 0, so as root. I set it to true and then privilege to true as well, but I later found out that it just needs privilege, which is scary enough. But now the reason it needs privileged is because it is running. So Zuul executor, to run a job, it uses something called bubble wrap, and bubble wrap is this thing that just wraps an execution of a process in a, isolated environment with very specific access to very specific things from the operating system, so that it prevents people to doing weird crap on your node, or things that you're not allowing them to do from within the process. So for instance, if you, without any specific configuration, if you run a Zuul job using Ansible and you try to access, I don't know, Etsy, like /Etsy from the host, it won't allow you because that directory has not been made available for you. Now, you can make that happen, but I wouldn't do it if I was you. Now, why do you need privilege? You don't need privilege true because bubble wrap. You need privilege true because for bubble wrap to create this unprivileged environment needs privilege access. So it's you need to give bubble wrap privilege access to whatever environment it is running on, so that it can create an unprivileged environment, an isolated environment for your containers to run jobs and shit. So another config that is very specific to oh, this is not the slide I was looking for. This is the slide I was looking for. Okay. So we like. I know it's like that is a Docker file. You don't have to read it, but I didn't have an image to put there, so I just like screenshotted my Docker file. We're currently adding some extra stuff into the Zuul executor. So every Zuul container out there is very slim. It has the bare minimum things that it needs to actually run, which is amazing. However, for more realistic cases or like scenarios, you do have to add some extra stuff in it. So this is what we add. We set the Ansible extra packages, which if you read the Docker file, you're going to see that it's not there because I'm currently setting that in the startup script, but it should be in the Docker file eventually. And the Ansible extra packages variable, what it allows you to. So one cool thing about Zuul, sorry, I keep going back and forth because Zuul is pretty cool. So whenever I remember something, I want to say it. So one cool thing about Zuul executor is that it supports multiple Ansible environments at the same time. So you can tell it what Ansible version you want to use from the set of Ansible versions supported by it, or if you want to install your own Ansible version, that you can probably do that. However, it supports a range of Ansible versions. Now, if you set the Ansible extra package environment variable, and then you run the magic command, which is like Zuul manage Ansible, it will install that Python package in every Ansible environment that there is and that it supports in your deployment. Now, we do this because we need some extra Python packages in these environments, like Bodo3 if you want to upload logs into AWS or whatever Google library if you want to use GCS or like talk to Google somehow. And all these packages are needed by the jobs themselves. So when we describe our base or pre-steps and our post steps for all the jobs, we require some of these tools. Again, everything we do is Vault managed. So whenever a job requires a Vault token to access some secret or some data, we don't submit the secret and the user to the job. What we do is we make a token which has a very tight TTL to it, available to the job, so that people that need access to Vault, they can do that at the very beginning of the job. So to do that, we need the Vault CLI tool available. kubectl if you want to run load on Kubernetes, you probably also need the kubectl CLI so that you can actually interact with Kubernetes. And the other thing that we inject, so to speak, is FileBit. So FileBit is actually an Elasticsearch product. FileBit, so login is a thing that Zuul knows basically nothing about. Like, the only thing that Zuul knows is that whatever job it runs is logging something, but it doesn't know what to do with that log, right? Unless you tell it what to do. What most of the people do, and like that is one of the cases in the OpenStack community, they download the logs from the worker, and then eventually those logs are uploaded somewhere in a probably static web file server that is then made available to consumers of Zuul. Now, we, being a company that processes and stores text and knows how to, manage and read text and do meaningful things with text, and also having a login service called Logstash, we are, of course, storing all the logs in an Elasticsearch cluster. So what we do is we install FileBit, which is a agent inside the executor container. And whenever the job finishes, what we do is we run FileBit one-off. It runs, it reads all the logs and uploads the logs into the Elasticsearch cluster, and all the logs are made available through Elasticsearch and Kibana and FileBit and Logstash, I'm sorry, so that consumers, and by consumers I mean engineers, can just go and find the logs there if needed. We also do some other stuff with the logs, like we parse it, and like for the Elasticsearch case where it is all Java and Java all the way down. At the very end of the job, normally there's this still, I'm not sure who's familiar with Java here, but I recently learned this. There's this thing called build scan that you can do with Gradle, and creates a full report of whatever Java did and the entire execution. So what we do is like we get the link to the build scan and make it available to other people. So these are kind of things that you will probably have to do with the login. The Zuul scheduler. All right, so one thing about the Zuul scheduler. So Zuul creates a secret key for every project that it is a project level. Okay, it creates a secret key for every project it manages. So for every project available or tested or managed by a tenant, it creates a secret key or a private key that you can use to encrypt keys and make them available, or encrypt secrets and make them available to your jobs. So if you have any secret information like credentials and stuff like that, and you don't have any other system in the back to like Vault to make those secrets available, or for some reason you want to have them in the source control in your Git repo, then you can do that by encrypting this secret and using the key generated by Zuul for the project. And then Zuul is going to do the whole job of decrypting the secret and make it available in plain text, so to speak, to the job itself. Now, the thing is that whenever you restart this scheduler, it will generate the keys again if you don't back them up. Now, this is extremely annoying because running Zuul scheduler within Kubernetes, it kind of makes you feel like you can restart everything every time and it's all going to be cool. It's not. So from Tobias, I got this thing or script that the review is in step number 2. It's actually on Gerrit, on review.openstack.org. It's a script that basically if you pass it a master key, it will use that master key to generate all the sub keys or child keys for every project. So you don't have, it doesn't matter that it is regenerating these keys every time you restart the scheduler because the master key is the same, so the secrets won't have to be regenerated every time. The other way to do it is that you back up your secrets and you make sure that those don't change and they are available to the scheduler at all times. But this one seemed to be more cloud native kind of thing. The scheduler is extremely annoying to restart. So every time you restart the scheduler, not only regenerates the keys, but it also resets the entire queue state for Zuul. So the scheduler is one of those services that you don't want to be restarting every time, or at least you want to have more of those. Except that there is a problem, and we're going to get to that. So there's this don't remember if I have to, yeah, there's this subcommand on the scheduler that you can call, which is reconfigure. And if you're changing, all right, so every time you change the scheduler configuration, you have to restart the scheduler, or you have to reconfigure the scheduler using the reconfigure command. And the reconfigure command is also quite disruptive. It's not as disruptive as restarting the scheduler, but it does something to the state. It loses some data every time you restart it. And this is not the ideal scenario, but this is like it by design kind of thing. Like this, like Zuul has worked this way for a very long time. It doesn't mean that it cannot be improved. It's probably going to be improved as HA scheduler is developed. But right now, it is the way it is. Now, every time you change the configuration, again, like you have to restart the scheduler. The problem with this is that the tenant configuration, whenever you define a tenant, like Zuul is multi-tenant by default. Even when you don't have tenants, you have tenants. So if you don't have tenants, you have at least one tenant, which is a default tenant. So you have to have a tenant. Every time you want to add a project to the tenant, you have to restart the scheduler or reconfigure it, which is extremely annoying if you are, slowly building your CI infrastructure based on Zuul. Now, there's a way around it, which is, and this is kind of like what we went with for now, but eventually, hopefully, it's gonna improve. We have a watcher on, so that we don't have to reconfigure it manually or restart it. We have a watcher on the configuration file, so every time the config map for the scheduler is updated, this watcher basically runs the reconfigure command, which again is a bit disruptive, but it's not as disruptive as restarting the whole scheduler. The main problem with the scheduler is that it's the only service in Zuul that is not HA. Like you can't have more than one scheduler today. If you have more than one scheduler, bad things are going to happen. And this is a limitation that the entire Zuul community is aware of, and there are proposals of making it HA and stuff like that. But it sounds horrible. It's horrible because it is your single pod of failure. So it's kind of like you want to be able to roll out new versions of the scheduler or like the entire Zuul deployment. So the way you would do that in a Kubernetes environment is that you just roll it out and you let one pod to restart and then the other one will restart and so on and so on. And you can do that. You can do that with most of Zuul except for the scheduler. So for the scheduler, there's always going to be some downtime whenever you want to update it. And again, it is your single pod of failure, but it's also one of the most critical pieces in the entire Zuul architecture. And the other thing I wanted to say about the scheduler is, I forgot. I'll come back to it later. But anyway, so, damn it, I forgot what I want to say. Anyway, so Zuul scheduler, extremely critical. You can have more than one of those these days, but eventually, like the whole team is working on making it HA and being able to have multiple of it. You can restart it more easily if you keep. There's a way to download the queue state from Zuul. If you download a snapshot, the queue state every like 5 minutes, which is it's not as terrible as it sounds. You can store the queue state, and if whenever you reload the scheduler, then you can inject the queue state back into the scheduler. All right, Zuul Web. Zuul Web is probably one of the simplest services to run. There's only one thing that we are doing these days. So the entire Zuul Web is behind OAuth for us. Mostly, like I think eventually is going to be, we haven't figured out what the best way to do this is. So we do have public-facing repos, but we also have internal repos. Like most of the repos at Elastic are public. So Elasticsearch CI, like Elasticsearch, Kibana, like all the bits are public. Most of the APM code and all the kind of things. So you can go on our GitHub organization and have access to all those. So we want to have CI for those, and we want CI for those to be, public as well, so that people, like external contributors, can go and look at their logs and look at what's happening. Right now, for Zuul, at least, it's not that way. So we have Zuul behind auth. So if you want to access the dashboard, you need to be an Elastic employee right now. But there's one endpoint that cannot be behind authentication, and it is the webhook endpoint, where Zuul Web receives all the events from Git. So this is what we did to make it happen. So we have a service for Zuul Web, which blocks everything and puts everything behind authentication. But we also have an extra service in Kubernetes for the webhook, which only accepts connections to this very specific path. And that is the way that we can kind of like pass through the authentication firewall that we put in front of it. And again, we haven't figured out what the best way for us to run this is. Eventually, we might have an instance of Zuul that is public-facing, another one that is internal, or we have the same Zuul for everyone if Zuul improves the security and role-based access control and granularity and all that. But we'll figure it out as we go. All right. So if you want to run CI load on Kubernetes, how am I doing in time? Okay. Jesus. So if you want to run CI load on Kubernetes, and this is the only slide I have on this topic, these are all the permissions that you have to. This is the permissions I have to give to your cluster role, and to which you are going to assign your service account that you're going to use to create it. So if you're using Kubernetes as a work management for your CI load, first and foremost, don't use the same cluster that you're using to run Zuul. That is a horrible idea. Have a separate cluster, because eventually load is going to go onto that cluster, and that's probably going to take down your CI cluster. Second, you want to have that as isolated as possible. And the way you do that, you give access to Zuul executor to that cluster, and you give access to Zuul executor to that cluster by using a service account, and the service account has to have all these permissions here. These permissions, however, are not entirely documented, and also this is one of the patches I have in my queue to push to the Zuul documentation. Now, maybe some of these might not be needed in the future, but for me to make it work, I had to give access to all these things. So I don't know what all of these permissions do. I mean, some of them are pretty obvious, like config maps, namespaces, and things like that, but I don't understand why Zuul executor needs access to control tabs, cron tabs, sorry. But whatever. If you don't give that, it's going to cry, it's going to crap out, and it's not going to work. So make it happen. And finally, I think, and this goes back to what I was saying at the very beginning of the talk, and Zuul scalability makes it really simple to start small. Like most of the time when you're trying to do capacity planning for whatever software that you have, people say like, start small and then grow as you need. Well, the thing is that if you start small with Zuul, you're probably not going to need to grow the deployment in a very long time, because little Zuul can do many big things. And this is fantastic because, at least in our case, it allows us to have a very small cluster that is manageable, is not consuming too many resources, is not spending too much money for us, and also be able to put some significant load on it and see how the rest of the company feels about it and about interacting. And also like how easy it is to maintain. Like I know it's super easy to maintain because of how it is and how it was designed, and because I also was part of the OpenStack community for a very long time. But not everyone is familiar with the deployment. So you want to give people that are actually going to operate the cluster time to, familiarize themselves with the deployment and see how easy or hard it is to maintain. But anyway, if you deploy a small Zuul cluster, it's actually going to take you a long way in terms of load. And that's all I have. Thank you very much. If there are no questions, I'm going to let you go. But if you have questions, I'm happy to answer them. All right, there's one.
Helm, Tiller or no?
Tiller, yeah. So far, yeah. Hopefully, we're just gonna roll out whenever the Helm known Tiller version is out. We're probably gonna be doing that. But right now, yes, just mostly because of historical reasons, it was there already, so we have all the data there. No more questions? Alrighty, thank you.